We are in a chapter called Circles in Mathematics. Circles is a very simple chapter in 10th standard mathematics it is. It's going to fetch you 4 marks. In the last class what I told you is the definition of the circle. What is a circle? Circle is a collection of all points in a plane which are at a constant distance from a fixed point called the center, and the constant distance is called the radius. To define the radius, I told you that when to write line, when to write line segment. In geometry we use the word line or straight line or line segment. When to write line, when to write line segment. Line segment is one which is having a specific limitations. We can't extend a line segment on either side, whereas a line is one which can be extended on either side infinitely. Therefore, radius is a line segment joining the center of the circle and any point on the circle. Radii of a circle are equal, and then the diameter is double the radius. Diameter is also a line segment which joins any 2 points on the circle passing through the center of the circle. And what is known as, when you know the length of the diameter, you can easily find the length of the radius, because diameter is twice the radius or radius is half of the diameter. Therefore, the conclusion part is both radius and diameter are line segments. There is one more line segment I introduced, that is called the chord. Chord is a line segment joining any 2 points on the circle. Then what is the relationship between a chord and a diameter? Diameter is the longest chord, right? Therefore, the 3 line segments I introduced in the previous class. One is the radius, diameter and the chord. Chord divides the circle into segments, whereas arcs forms, radii forms as what is known as sectors. Sectors are different from segments. Then I told you something about the circumference. Circumference is nothing but the boundary of the circle or perimeter of the circle. It is given by the formula 2 pi r. The area of a circle is given by pi r square. Then what is that pi? Pi is an irrational number and its approximate value is 22 by 7. All these things are we learned in the previous classes. Now today's class is we are going to learn about the lines and the circles. In the previous class we understood that line segment and a circle. Now I am going to explain you the relation of line with circle. See, what I do is I draw a circle. See, first to draw a circle, first you have to identify the fixed point. The fixed point is called what? Center. Now this is a circle. I draw a circle. Circle is drawn with the help of a compass. I draw a circle. I name the center of the circle as O. In your textbook they are written 2 lines. Try to understand. Line. See, this is a line. Line means, now I write this as AB. AB is a line. Be careful, it is not a line segment. It is a line. Line means I can extend on both sides. There is no measurement in this particular line. AB is a line. Now tell me, what is the relationship between AB, the line AB, and the circle? No relation. This line is independent of the circle. Circle is independent from the line. Therefore, there is no relationship between the line AB and the circle. Now imagine a situation. I make this line, it is a line. Consider my scale, the scale as line AB. Now I move this line like this. Is there any relation? No relation. I still move like this. Is there any relation? No relation. Is there any relation? No relation. If I come and make this line to get a contact with the circle, then there is a relation. See? There is a relation here. Now I call this as A dash B dash. See, there is a relation. This line AB, A dash B dash, touches the circle. Now again, I move the circle, what is known as the line AB like this. There is a relation. I write this as A double dash, B double dash. Now see, when any line is there, that line can have three different types of relation with the circle. One is, the line may not have any relation. The line may come and touch the circle at one point, or that line may cut the circle at two distinct points. Other than that, we can't think any relation between a circle and a line. Between a circle and line, we have three different conditions. One is, the circle and line have no relation. Circle and line, the line touches the circle at a point, and line cuts the circle at two distinct points. Therefore, see, the first condition is A dash, B dash, where the line is touching the circle at only one point, that line is called a tangent. That line is called a tangent. Tangent is a line which touches the circle at only one point. Simple, no it is. Is tangent is a line segment? No. Tangent is a line, straight line. It touches the circle at how many points? Only one point. That is called the tangent. Then there is a line. This line cuts the circle at or intersect the circle at two distinct points. Two distinct points. That is called a secant. Secant. Now see children, both tangent and secant are lines. Both tangent and secant are lines. Tangent is a line, secant is a line. What is a tangent? Tangent is a line which intersects the circle at only one point. Like that also we can write your textbook, they are written like that. It is better to write touches instead of to write intersects, right? Like tangent is a line which touches the circle at only one point. Secant is a line which intersects the circle at 2 points. But both are belongs to a group of line. They are not line segments. Therefore, in this diagram we can understand what is the relationship between AB and this circle? No relation, because there is no intersecting or touching points between the line and the circle. But in the case of A dash B dash is a line which touches the circle at only one point. We call that line as a tangent. Whereas A double dash and B double dash is a line which cuts or intersects the circle at two distinct points. These are the points, two distinct points, and we call them that line as a secant. Therefore, today's class I am introducing two more parameters related to the circle. One is the tangent, another one is the secant. You have one sort of information related to tangent and a secant, right? Secant is a line which intersects the circle at two distinct points. Tangent is a line which touches the circle at only one point, right? I told you that tangent is a line. Now I write, see here there is a circle with center O. I write a tangent. What is a tangent? Tangent is a line. Tangent is a line. Line means I can extend these two. Tangent is a line. Now I call this as ED. Tangent is a line which touches the circle at only one point. Only one point. I call this point as, I name this point as P. This AB is a line. It touches the circle at one point, that is P, and this point is called point of contact. Point of contact. Now two things. What is a tangent? I write. What is tangent? Tangent is a line Tangent is a line which touches the circle, at only one point. Tangent is a line which touches the circle at only one point. What is the name of the point I call? I call that point as point of contact. Right? Now see here. For this circle I draw a line. This is a line. This is a line. I call this line as PQ. This PQ is cutting. PQ is intersecting the circle at two different points. And therefore, this line is called a secant. Secant is a line which cuts the circle at two distinct points. Whereas tangent is a circle which touches the circle at, the tangent is a line which touches the circle at one point, and that point is called the point of contact. Try to understand this. Very simple it is. What is secant? What is tangent? Now remember 5 things. Radius, diameter, chord, tangent, secant. Tangent and secant are lines. Radius, chord and diameter are straight lines or line segments. Now see, sometimes they may ask you, they may make you to get confused. See, I write a line like this, AB I have written. If I write AB is a line, then what is it for the circle? If AB is a line, then what is the position of AB with respect to the circle? If AB is a line, then AB is a secant. Why? Because if AB is a line, that can be extended. Suppose AB is a line segment. AB is a line segment. When AB is a line segment, I can't extend. Try to understand this. Very simple. If they are given AB is a line, then you have to guess. If AB is a line, then AB can be a secant. If AB is a line segment, then it is a chord. That is the difference. I repeat once again. I make you to understand this. Whenever they give any concept like this, you have to always be careful about the word line and line segment. Suppose, see, in the diagram, they have written a structure like this. They name this line as PQ. Now you have to ask, what is this PQ? Before they ask, you have to ask, what is this PQ? Is PQ is a line. PQ is a line segment. PQ is a line segment. If PQ is a line, then it should be a what? Secant. If PQ is a line segment, then it is a chord. Try to understand the word, how much it changes. If it is a line, it is a secant. If it is a line segment, it is a chord. Why? Because if it is a line, it means to say that it can be extended. It can be extended. Line can be extended, whereas line segment cannot be extended. You should be very careful about while writing the definition of a line and a line segment. If you write PQ is a line segment called a chord, right? PQ is a line called chord, wrong it is. A line means it can be extended. That you have to understand. The one more thing is, see, I write a secant here. Secant. Secant means what? Secant is a straight line. It can be extended. I call this as AB. AB. If I make this secant to move away from the center, see, if I move like this, it is A dash, B dash, right? Now see, these two are the points. Now they come closer. They come closer. Again I write it here. Those 2 points are closer. And now I move the scale. See, this is a secant. This is a secant. This is the secant. This is the secant. This is the secant. Now it becomes a tangent. The secant, when it moves away from the circle, at one particular point, both the intersecting points, they coincide and becomes one point. When it becomes one point, we can say that it is a tangent. I repeat it again. This is what? Secant. Secant is a line which intersects the circle at 2 points. When I move the secant away from the center, these two intersecting points, they come closer to each other. At one particular point, both the intersecting points, they coincide as one point. At that time, that line becomes a tangent. Therefore, this concludes that in a circle, at any one point, we can draw only one tangent. I repeat once again, we can draw only one tangent to a circle at any point. For example, on a circle, here there is a point. I call this point as P. At this point, how many tangents you can draw? Only one. Only one tangent can be drawn to a circle at any point on it. Suppose here there is a circle, here there is a point Q. How many tangents I can draw at the point Q? Only one. Only one tangent can be drawn to a circle at any point on it. Therefore, try to understand, we can draw infinite tangents to a circle because circle is formed by infinite number of points. Infinite number of points. At every point, we can draw only one tangent. At a point, we can draw one tangent, but a circle can have infinite number of tangents. Okay? Now I repeat once again, you should not get confused with a tangent and a secant. Tangent is a line which touches the circle only at one point, and that point is called point of contact. Secant is a line which intersects the circle at 2 different points, 2 distinct points. And when we move the secant away from the center, those 2 intersecting points come closer to each other. At one particular position, both the intersecting points, they coincide. At that time, the secant becomes a tangent. Therefore, that concludes that, what is that? We can draw only one tangent to a circle at any point, at any one point. Right? But how many tangents we can draw to a circle? We can draw infinite number of tangents. But at a particular point, we can draw only one tangent. Right? And the tangent is a line. Whereas radius, chord and diameter are line segments. Therefore, while writing, we should be very careful. There is a line, what it is. Suppose see, some of the books, they are written like this. See, I write a circle, you have to tell me what it is. See here, I draw a circle. I draw a circle like this, this is a circle. Now I write a line. I write a line here. What is this AB to this circle? Then you have to ask, what is this AB? First tell me. Sir, AB is a line. AB is a line means I tell it is a secant. Why? Because if AB is a line, then it can be extended. If AB is a line, that can be extended. When they extend that, they are going to intersect the circle at two distinct points, then it becomes a secant. Suppose he tells AB is a line segment, then you tell AB is not having any relation with the circle. Very simple. Therefore, be careful about tangent, secant, line and line segment. Tangent and secant are lines, whereas chord, radius and diameter are line segments. Tangent is a straight line which touches the circle at only one point, and that point is called the point of contact. At any point on the circle, we can draw only one tangent to the circle, but we can draw infinite number of tangents to a circle at different points. Now we know the difference between a tangent and a secant. Tangent is a line which touches the circle at only one point, and that point is called the point of contact. At any point on the circle, we can draw only one tangent, right? Same way, the secant is a line which intersects with the circle at two distinct points. When you move the secant away from the center, at particular point, two intersecting points, they coincide and becomes a point of contact, and that line becomes a tangent. Simple it is. Right, now the question is, I write you have to tell me what it is. I write a line. Always I am very giving emphasis to the line and line segment. What it is? If it is a line, it is a secant. PQ is a secant. What is that? PQ is a secant. Now what I do is, I keep the scale on the PQ. Right? Now I move the scale away from the center. Away from the center like this. It is a secant, 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 it is a secant. Now it becomes a tangent. In this experiment, what I told you, what I did is, this P dash and Q dash is parallel to the PQ. PQ is a secant and P dash Q dash is a tangent. Why? Because these 2 points they intersect at here. And this point is called what? Point of contact. Same way, I keep the secant here. I move the secant that side. Like this. Now secant is moving this side. I come here. Here it becomes a tangent again. Here there is a point. If you consider this is parallel to this is also parallel to this. Therefore, in this diagram, how many tangents are there? 2 tangents. How many secants is there? Only 1 secant. But what is the relationship between these 3 lines? They are all parallel to each other. That infers us we can draw only 2 parallel tangents. Try to understand. Only 2 parallel tangents to a circle. This is parallel to this. Only 2 parallel tangents to a circle. Suppose if I draw a tangent here, if I draw a tangent at this particular point, then the parallel tangent to this tangent may come here somewhere. Therefore, for a circle, we can draw only 2 parallel tangents. We can't get more number of parallel tangents to a circle. Therefore, the properties of tangents you have to understand. Tangent is a line, first one. Tangent touches the circle only at one point. What is the name of the point? Point of contact. And how many such tangents can be drawn to a circle at any point? Only one. Right? And how many parallel tangents we can draw to a circle at any point? 2. That we have to clarify before venturing into the problems related to this chapter called circles. Now, see, I write a tangent again. This chapter is mainly based on the tangent. See, I draw a tangent. Now AB is a tangent. AB is what? AB is a tangent. Tangent means, how can I say that it is a tangent? Because it touches the circle at only one point, and that point is called point of contact. P is called point of contact. Where is that point P? It is on the circle. The point P is on the circle, and P is also on the tangent. Point P is on the circle and also on the tangent. And at point P, both the circle and the tangent intersects. Now at the point P, if I draw, because since the point P is on the circle, I join a line segment connecting the center and the point P. It becomes what? It becomes a radius. P is a point on the circle. AB is a tangent, it touches the circle at the point P. Then point P is the point of contact, and P is on the circle. Therefore, if I join the center and the point of contact, I get the radius. Now the funniest thing is, the radius and the tangent at the point of contact is always perpendicular. It always perpendicular. Very important relation you have to remember to solve the problem related to circles, that too pertaining to tangents. Radius and tangent, how are they related? Radius and tangent are related perpendicular to each other, but where? At the point of contact. At the point of contact, radius and tangent are perpendicular to each other. That we have to always remember, very important. Now see, what are the characteristics? Now again I repeat. Tangent is a line, right? Tangent is a line. Tangent touches the circle at how many points? 1 point. What is the name of the point? Point of contact. How many tangents can be drawn to a circle at any point on it? Only one. How many parallel tangents we can draw to a circle? Only two. How the tangent and radius are related at the point of contact? They are perpendicular, 90 degrees. It is a basic knowledge you have to keep in your mind to solve the problems of based on circles and tangent. Radius and tangent are perpendicular to each other at the point of contact. And this tangent touches the circle at only one point. Only one point. That point is called point of contact. This point of contact is also on the circle. Therefore, the intersection of the circle and the tangent is only at one point. At that point, we can draw only one tangent and one radius, and radius and tangent are perpendicular to each other at the point of contact. Based on this, there is a small logical theorem. See, children, you have solved, we have proved many number of theorems, particularly in 10th standard. So far you completed 3 theorems. But now we are going to prove a theorem. This theorem is a logical theorem. There is nothing in this theorem, only the argumentation. This theorem, once it came for the public examination, it is a theorem of 2 marks. Very simple theorem. What it tells? Tangent. See, I repeat in the statement. Tangent at any point of a circle. Tangent at any point of a circle is perpendicular to the radius through the point of contact. I repeat once again. See how nice it is. I write a rough diagram. See, here if this is a circle, tangent to a circle at any point, see it's a point. Tangent at any point of a circle is perpendicular to the radius to the point of contact. This angle is 90. Therefore, always remember this statement. Statement is very important for solving the problem. Tangent at any point on the circle is perpendicular to the radius through the point of contact. This theorem we are going to prove with the help of a theorem. This theorem is a 1 mark or 2 mark theorem because it doesn't have anything, only the argumentation is there. That argumentation I am going to tell you. So far what all I told you is a tangent. What is a tangent? Tangent is a line or a straight line which touches the circle at one point, and that point is called point of contact. At any point we can draw only one tangent to the circle. At the most we can have two parallel tangents to a circle, and then the radius and tangent are perpendicular to each other at the point of contact. This is a very important concept related to what is known as tangents. Try to understand, children. The application of tangents are used in various factors like escalators, belt-driven vehicles, chain-driven vehicles, even scooters, bicycles, escalators, and conveyor belts. They're all, we are going to use the concept of tangent at a circle. Even in robotics, robotic arm, the robo, how to make the fingers to move and how the arms are moving, how the robot can walk. These are all based on tangent and a circle relation. Therefore, if anybody interested in robotics, they have to always, anything they do with the help of motors and belts, conveyor belt, those children has to learn this very much, in a very much interest. Why? Because in future classes also, this application is going to use by you. Therefore, try to understand tangents. For example, I written a diagram here. I am sure that you are going to understand what is this diagram is. This is a wheel of a car. Wheel of a car. And this is a road. Wheel of a cart is having number of spokes. These spokes are nothing but radius. They are all radii of this particular circular. The wheel is in the circular in shape. When the wheel of the cart is moving, the spokes, the one particular spoke makes a perpendicular contact with the road. Therefore, you can imagine how many vehicles are moving on the road. All those vehicles having wheels, and these wheels having a contact with the road. For road is a tangent to the wheel, and the spokes becoming what is known as their radii. At one particular point, they become perpendicular to the road. That is the concept. Therefore, the idea of this diagram is there may be many number of radii, but one radii becomes perpendicular at one particular instant of time. Not all the radii are becoming perpendicular all the time. Only one radii is going to become perpendicular to the road and at the point of contact. That is the statement of the theorem of related to the tangent. The statement is like this. A tangent at any point of a circle. See the statement? The tangent at any point of a circle. If there is a tangent at any point of a circle is perpendicular. Perpendicular to what? Perpendicular to the radius to the point of contact. I repeat once again. Tangent at any point on a circle. The circle is having a many number of points. Tangent to any point of a circle is perpendicular. Is perpendicular to what? Perpendicular to radius. Where? At the point of contact. That is the statement of the theorem. Very simple theorem. There is nothing in there in the theorem they are given in the textbook. It is only argumentation. Argumentation part is there. I am going to prove this particular theorem. The theorem tells that the tangent at any point of a circle is perpendicular to the radius through the point of contact. For to prove this particular theorem, I require a diagram. The diagram is like this. See, this is the center. First I mark the center. I draw a circle. Now I am writing what is known as the figure related to the theorem. What is the theorem? Tangent at any point of a circle is perpendicular to the radius to the point of contact. See, this is the circle item. Now I identify tangent at any point of the circle. Now I mark this point as P. Tangent at any point of the circle means I write tangent here. I tangent here. Now I name this tangent as xy. Tangent is nothing but a line, straight line. This can be extended. Is perpendicular to what? Is perpendicular to, I write that side, is perpendicular to the radius to the point of contact. We have to write the radius to the point of contact. Right? I repeat once again. The statement is very simple. Tangent at any point of a circle. Tangent at any point of a circle is perpendicular to the radius to the point of contact. This is the diagram of the theorem. Statement of the theorem is tangent and radius are perpendicular to each other at the point of contact. That is the statement. This is the diagram. Now what should I do? I write the data path. Data. O is the center. O is the center of the circle. Center of the circle. XY is the tangent. I write this like this because I always give emphasis to line and a line segment. XY is a tangent. And P is a point of contact. Point of contact. O is the center, XY is the tangent, P is the point of contact. There is one more line segment we left, that is OP. OP is the radius. OP is the radius. I repeat once again. The statement is the tangent at any point of a circle is perpendicular to the radius through the point of contact. The diagram is, here there is a circle with center O, XY is the tangent, P is the point of contact, OP is the radius. Now I have to prove that this angle P is equal to 90 degrees, or TPT is like this. TPT. I wanted to prove that OP perpendicular to XY. OP is perpendicular to XY. Or OPY is equal to 90 degrees. That I have to prove. Simple, right? Now, to prove this one, there is a construction. The construction is like this. See, XY is a tangent and P is a point of contact. What I do is, I mark a point, what is known as Q. See, I mark a point Q on XY. This Q is on XY. Mark a point Q on XY and then I join this. And I join this. Q is a point on XY, join OQ. That is my statement in the construction. Construction is mark a point Q on XY and join OQ. Join OQ. I repeat once again. The statement is tangent at any point of a circle is perpendicular to the radius through the point of contact. Circle with center O, XY is the tangent, P is the point of contact and OP is the radius. What I have to prove? OP is perpendicular to XY. I have to prove. For that proof, I require a construction. The construction is mark a point Q on XY, join OP. Now I write the proof part of this. You have to keenly observe the theorem and you have to write the theorem. This week test I am going to give this particular theorem. Now I will for the proof of this particular theorem. The proof tells like this. Very simple proof. See, Q is a point on XY. What is that XY? XY is a tangent. Which is the point of contact? P. Therefore, XY touches the circle only at P. Therefore, Q should be a point outside the circle. I repeat once again. XY is a tangent. P is a point. P is a point of contact. Therefore, Q is a point outside the circle, because all other points other than the P are not touching the circle, what is known as its center O. Try to understand, I repeat. Q is a point outside the circle. First line. Q is a point. Q is a point. Q is a point outside the circle. First line you have to remember. Q is a point outside the circle. Why? Because XY is a tangent. XY is a tangent and P is the point of contact. P is the point of contact. If P is the point of contact, then all other points on the XY should be outside the circle. That is a simple argument here. Q is a point outside the circle. How you understood? Because XY is a tangent. P is the point of contact. Therefore, any other points other than the P should be lies outside the circle. That is the argument in this. Therefore, come back to the diagram here. Therefore, when you consider the length of OQ and OP, which one is bigger? Point on XY and Q is a point outside the circle. Therefore, OQ is greater than OP. P is a point touching the circle. Q is a point outside the circle. Therefore, the shortest distance is OP. It is not the OQ. Therefore, OQ is greater than OP. This is the only thing you have to write. OQ is greater than OP. Simple no it is. I repeat once again. XY is a tangent, P is a point of contact, P touches the circle. So P is on the circle. It is a point of contact. Therefore, any point on this line XY should be outside the circle. Q is a point on the XY, therefore Q should be outside the circle. Therefore, OQ should be greater than OP. Right? Because OP is the radius, and since it is outside the circle means it is bigger than the radius, therefore OQ is greater than. Now imagine children, we have to write one statement like this. Any point, if I mark any point here other than P, all other points are outside the circle. Therefore, OP is the shortest distance. OP is what? OP is the shortest distance between O and XY. If you wanted to get a shortest distance from O to XY, which is the shortest distance? OP is the shortest distance. Therefore, OP is the shortest. OP is the shortest distance. OP is the shortest distance between O and XY. O and XY. O is the center of the circle, XY is the tangent. OP is the shortest distance between O and XY. And you all know that shortest distance should be always perpendicular. Therefore, OP is perpendicular. OP is perpendicular to XY. That ends the theorem. OP is perpendicular to XY. That ends the theorem. I repeat once again. This theorem is of theorem of 2 marks. Very simple, easiest theorem in the world it is. Don't say that it is difficult. It is the easiest theorem. The theorem tells like this. The statement is, tangent at any point of a circle is perpendicular to the radius through the point of contact. The diagram is like this. O is the center of the circle. Here there is a circle. XY is a tangent. Tangent has to touch the circle at one point. That point is called the point of contact, that is P. Through the P, radius is drawn. OP is the radius. Now, the data is O is the center. XY is the tangent, P is the point of contact and OP is the radius. What should I prove? OP is perpendicular to XY. For that purpose I do a construction, that is, I mark a point on XY called Q, then I join OQ. Now my argument is Q is a point outside the circle. That is the first argument. Q is a point outside the circle. How can I say that? Because XY is a tangent and P is the point of contact. The XY touches the circle only at P. Therefore, all other points are outside the circle. Right? It cannot be inside the circle. If it is inside the circle, then XY becomes a secant. Therefore, Q is a point outside the circle. Therefore, OQ should be greater than OQ. OQ should be greater than OQ. By that, what we understand is, all other points on XY are outside the circle. Therefore, OP is the shortest distance between O and XY. Shortest distance should be always perpendicular. Shortest distance should be always perpendicular. That basic concept you should understand. Since OP is the shortest distance is always perpendicular, therefore OP is perpendicular to XY. That ends the theorem. This theorem is, I am going to give this theorem in this week's test only, and you have to practice. So far you have completed 4 theorems. We have only 5 theorems, 6 theorems in the 10th standard. 4 theorems we completed, and this is a very important theorem. But this theorem fetches you very less marks. That is because nothing is there. Only one statement. OQ is greater than OP. That is the major statement of this particular theorem. Assignment number 130. First question is fill in the blanks. You have to fill the blanks using the words line or line segment. First one, radius is dash. You have to fill either line or line segment. B, tangent is dash. C, chord is dash. Secant is a dash. Diameter is a dash. You have to use only those 2 words, line or line segment. Second question, define the terms tangent and secant. Third one, tangent touches the circle at one point called dash. What is the name of the point? You have to write. Fourth one, radius and tangent are dashed to each other at the point of contact. Fifth one, how many parallel tangents a circle can have? Sixth question is the theorem. Very simple theorem. Tangent at any point of a circle is perpendicular to the radius through the point of contact. Prove. This theorem I am going to give this week test. Therefore, practice properly. Thank you.